Introducing Neo-Mon, a cheap, non-invasive alternative for the monitoring of neonatal vital signs. Neo-Mon is designed for developing countries where nurses are required to manually oversee the health of newborns. With Neo-Mon, hospitals are equipped with an automatic detection system that is able to monitor a neonate's heart rate, breathing rate, as well as core temperature.
Let's now talk about how it works. Neo-Mon comes with 3 sensors: an EMG sensor that measures breathing rate by recording intercostal muscle activity. The electrodes are placed on the 7th and 8th intercostal muscles of the neonate, with a reference electrode on the hip. An ECG sensor that measures heart rate. The electrodes are placed over the heart as shown, with the reference electrode placed towards the collarbone. Finally, an NTC thermistor to measure core temperature. This circuit will be attached to the neonate's stomach. All electrodes will be secured in place by a silk scarf to minimize any irritation, as well as minimize movement artifacts while the sensors are operating. Any abnormalities detected during operation will cause an LED signal to light up.
Using a MyReal device, we're able to take the information from each sensor and represent the information as the neonate's vital signals in a user-friendly front panel. For the demonstration purposes, as the graph shown for the EMG and ECG signals have been simulated with the LabVIEW biomedical toolkits. Here we have the raw signals from EMG, ECG, and thermistor. With our unique filtering techniques, here are the refined signals. We see the average spike in the EMG graph represented breath taking in, while its average spike in the ECG graph represented heartbeat.
Over here is the data analysis section, which numerizes these values. Let's now demonstrate how LEDs function. Our designated threshold for breathing is 40 to 60 breaths per minute. Our threshold for heart rate is 120 to 160 beats per minute, whilst our threshold for temperature is 35 to 37 degrees Celsius. At the moment, we have set the simulated signal for EMG to be below the threshold, which means the LED is currently lit. The simulated signal for ECG is set to be over the threshold, which means the LED is similarly expected to be lit. Whereas the temperature sensor, currently measuring the subject's body, is within the temperature range, meaning the LED will not be triggered. Hence, the LEDs are able to work simultaneously and independent of one another. These LEDs therefore act as warning signs to automatically notify nurses to check the well-being of the neonate.
With the convenience that the device offers, we hope that this could be rolled out in developing countries soon. Nurses could more accurately track the well-being of each baby and deliver treatment accordingly.